Parallel databases. Companies need to handle huge amount of data with high data transfer rate. The client server and centralized system is not much efficient. The need to improve the efficiency gave birth to the concept of parallel databases. Parallel database system improves performance of data processing using multiple resources in parallel, like multiple CPU and disks are used in parallel. There are several architectural models for parallel machines. These models are shared memory, shared disk, shared nothing, hierarchical. So these are four architectures: shared memory architecture, shared disk architecture, shared nothing architecture, and hierarchical architecture. So let's see each architecture in detail. Shared memory. In a shared memory architecture, the processors and disks have access to a common memory, typically via a bus or through an interconnection network. The benefit of shared memory is extremely efficient communication between processors. Data in a shared memory can be accessed by any processor without being moved with software. A processor can send messages to other processors much faster by using memory writes, which usually take less than a microsecond, than by sending a message through a communication mechanism. The downside of shared memory machines is that the architecture is not scalable beyond 32 or 64 processors because the bus or the interconnection network becomes a bottleneck since it is shared by all processors. Adding more processors does not help after a point since the processors will spend most of their time waiting for their turn on the bus to access memory. Shared memory architectures usually have large memory cache at each processor so that referencing of the shared memory is avoided whenever possible. Shared disk. In the shared disk model, all processors can access all disks directly via an interconnection network, but the processor have private memories. These are two advantages of this architecture over shared memory architecture. Since each processor has its own memory, the memory bus is not a bottleneck. It offers a cheap way to provide a degree of fault tolerance. If a processor or its memory fails, the other processors can take over its task since the database is resident on disks that are accessible from all processors. The shared disk architecture has found acceptance in many applications. The main problem with a shared disk system is again scalability. Although the memory bus is no longer a bottleneck, the interconnection to the disk subsystem is now a bottleneck. It is particularly so in a situation where the database makes a large number of accesses to disk compared to shared memory system. Shared nothing. In a shared nothing system, each node of the machine consists of processor memory and one or more disks. The processors at one node may communicate with another processor at another node by a high-speed interconnection network. Shared nothing architectures are more scalable and can easily support a large number of processors. The main drawbacks of shared nothing systems are the cost of communication and of non-local disk access, which are higher than a shared memory or shared disk architecture since sending data involves software interaction at both ends. Hierarchical. The hierarchical architecture combines the characteristics of shared memory, shared disk, and shared nothing architectures. At the top level, the system consists of nodes that are connected by an interconnection network and do not share disk or memory with one another. Thus, the top level is a shared nothing architecture. Each node of the system could actually be a shared memory system with a few processors. Alternatively, each node could be a shared disk system, and each of the systems sharing a set of disks could be a shared memory system. Thus, a system could be built as a hierarchy with shared memory architecture with a few processors at the base and a shared nothing architecture at the top, with possibly a shared disk architecture in the middle. Thank you.